Hi everyone, this is Ulaş Kozat from the MAGMA team at Facebook Connectivity. In my presentation, I will talk about MAGMA's mission, its ecosystem, its high-level architecture, and the roadmap that we planned for this calendar year. MAGMA's mission is very much in line with the Facebook Connectivity's mission. We want to connect the world to a faster network by enabling service providers to build cost-effective, extensible, and carrier-grade networks. MAGMA has been open-sourced more than 2 years ago. Since then, its ecosystem is growing steadily. Today, MAGMA is backed by big world-class open-source organizations such as the Linux Foundation, Open Infra Foundation, Telecom Infra Project, and OpenAirInterface. It has been adopted and deployed by many value-added sellers and system integrators, cloud providers, OEMs, ISPs, and MNOs. When we look at the GitHub activities, we see a very healthy picture as well. We are averaging about 50 commits per week onto our master branch. We are observing hundreds of thousands of clones on a bi-weekly basis, among which there are more than 1,200 unique cloners. In terms of visits to our main landing page, we see tens of thousands of visits, again on a bi-weekly basis, among which more than 1,300 are unique visitors. These unique cloners and unique visitors, in terms of numbers, are 2 orders of magnitude larger than the direct contributors from Facebook team. So this shows the health of the ecosystem. Speaking about contributions from the community to MAGMA, OAI holds a special place. They help us to develop many features, help us on the DevOps and testing infra side, and they also play an important role in the governance and directions. Just to give you examples, 5G NSA support that will be mostly be part of the 1.6 release is developed by Mohit and Lionel from the OAI team. Again, Mohit and Lionel is working towards NB-IoT support, and the first set of features will be available by 1.7 release timeline. Rafael has been helping a lot on the DevOps and testing infra and leading some of the efforts there. Even on the 5G SA testing and troubleshooting, we have a lot of collaboration with TN team. In terms of governance and directions, Lionel is a code maintainer for the MME code, and Rafael is one of the 5 TSC members. For folks who are not familiar with the MAGMA architecture, I want to spend some time on this. MAGMA is a distributed converged core solution. As such, it has 3 very distinct components. The highly distributed part of MAGMA is called Access Gateway. It implements both control plane and user plane functions so that you can connect your 4G, 5G, and Wi-Fi based radio access network to this Access Gateway at the very edge. Through the Access Gateway, users can easily access to their edge cloud or the internet. The next layer is the orchestrator. Orchestrator provides RESTful APIs for configuration, visualization, policy and subscriber management, and lifecycle management. Out of the box, we also provide network management service that utilizes those RESTful APIs so that a graphical user interface can be exposed to the end users. Last but not the least, we have the Federation Gateway. When mobile network operators want to utilize third-party products such as PCRF, HSS, OCS, or Packet Gateway, they can deploy the Federation Gateway in their network that supports all the standard interfaces towards those functions. MAGMA has a very unique perspective in terms of how Converged Core should look like. When we talk about Converged Core, our intention is not to really provide a set of functions that only does 4G that only does 5G or that only does Wi-Fi. Instead, we build our platform on top of common reusable services. The tricky part is how we terminate the connections to the other functions or nodes that are following the standard spec. Our answer to that question is, on the southbound side, to terminate the control path as early as possible. As soon as, for example, the HTTP connection ends, we should start using reusable services in terms of access control, IP address management, session management, and data path control. On the data path, instead of providing separate user plane functions to cater for the connectivity, we rely on a unified programmable data path so that we can connect 4G base station, 5G base station, or Wi-Fi access point directly to the same access gateway. On the northbound, again, we don't want to redesign our services as the OSS, BSS functions are changing from one technology to other, from one generation to another. For that reason, we, again, terminate those connections as early as possible and turn them into our internal API calls and data structures. Hence, when we look at the 4G, 5G Converged Core architecture, you won't be seeing under the hood a very separate 5G specific implementation. You will see that 90% of the services are reused. Here, for example, I show some of the touch points like NGAP and 5G NAS that are responsible for terminating and translating N1 and N2 connections and procedures. The 5G connection point here is not very different than the 4G connection point. It just listens on a different HTTP port. That's it. And both G node B and E node B connects to the same Open vSwitch path. So one can actually take our access gateway, deploy it, just enable the 5G configurations, attach a E node B, attach a G node B, and can provide both 4G and 5G sessions at the same time. Let's look at the MAGMA roadmap in the final part of my presentation. We have been very busy this year. We already have delivered 2 releases, 1.4 and 1.5. Currently, we are working for the 1.6 release, and we will do 2 more releases by the end of this year. As of release 1.4, out of the box, access gateway are running as stateless services. That means when there are crashes happening, or when there are software upgrades or there are config changes that require service restarts, we don't lose data connectivity for the existing sessions. We provide cloud-based HA, we provide header enrichment. Orchestrator is refactored to do a full service mesh-based architecture. We added call tracing, and we also added general usability improvements in 1.4. In 1.5, the biggest feature we added was inbound roaming. We added S1 mobility, Ubuntu support, release 15 upgrades, Cloud DB refactoring, PLMN, and IMEI restriction support. In 1.6, the main features that we are adding is 5G NSA support, a lot of stability and scale improvements, service area restriction, and lawful interception. For 1.7, the biggest target we are looking for is to provide a stable fixed wireless access 5G standalone architecture support. We also want to provide emergency attach, MB-IoT, and IPv6 support as part of 1.7 release. Mobility extensions and access gateway containerization are the other 2 things that we are going to look into. For release 1.8, we will extending over our 5G feature capabilities, as well as adding more robustness and more features for the existing services. If we zoom into the 5G roadmap, historically, we started 5G standalone architecture support in Q3 last year. Later on, we also start addition of 5G NSA support. We demonstrated a pre-alpha versions of both technologies, both features, in MAGMA Developer Summit early in this year. As of today, we can show in various test scenarios that 5G NSA feature is working on our master branch. The only caveat is still the data rates we limit to a few hundred megabits per second. And for fixed wireless access, an alpha version will be available, on our 5G, MAGMA 5G branch. In the coming weeks, we will be migrating MAGMA 5G branch to the master branch, and we will be phasing out 5G branch completely. MAGMA is a monorepo project, and we want to keep that moving forward. After we land our code on the master, we need a bit more further stabilization and more scaling. With those features landing, we will release formally a 5G fixed wireless access product by the 1.7 release timeline. After that, we will be more focusing on productionizing more policy and subscriber extension related parts, as well as landing some slicing foundations. And next year, we will be spending more time on the slicing support. MAGMA is a journey that started quite some time ago, and this journey is continuing very strongly. And I invite everyone to join to this journey. Thank you.